Welcome to Hydrology Hub. In this lecture, we will discuss the emergency action plan for dams. We will understand what is EAP, why it is important, and what should be there in EAP. A dam is one of the most valuable national asset. It supports irrigation, hydropower generation, flood control, drinking water supply, and industrial development. However, if a dam faces distress and emergency preparedness is poor, it can become a source of catastrophic disaster. That is why EAP is essential. An emergency action plan is not a just report prepared for compliance. It is practical action document that answers who will do what, when, where, and how during a dam emergency. Its ultimate purpose is first, save the dam, and if that is not possible, save human lives. One live example is the Machu Dam failure in Morbi, Gujarat in 1979 is one of India's worst dam disasters. Thousands of people died because warning systems were weak and emergency response was inadequate. That tragedy taught us that dam safety is not only engineering, it is preparedness. Dams can face emergencies due to many reasons such as overtopping during the extreme floods, internal erosion or piping, excessive seepage, cracks in embankment or concrete structures, slope failure, spillway gate malfunction, foundation instability, earthquakes, landslides into reservoirs, saboteurs, or human error. When such emergencies occur, the biggest problem is confusion. People begin asking who should inform the district collector, who will alert the police, who will warn downstream villages, who will coordinate evacuation. If this is not predefined, valuable time is lost. That is why EAP is required. It clearly outlines who does what, where, when, and how. One live example is during the Kedarnath flood disaster of 2013, delayed warning and poor coordination increased losses. Preparedness could have reduced the impact. In dam safety, delay of even 30 minutes can cost hundreds of lives. Now, the Dam Safety Act. Dam Safety Act 2021 provides the legal framework for dam safety management in India. This act clearly states that every dam owner must first conduct a risk assessment study. This helps identify possible failure modes and downstream consequences. The first study must be completed within 5 years. Second, prepare an emergency action plan, again within 5 years for existing dams. Third, for new dams, EAP must be prepared before the initial filling of the reservoir. This is very important because emergency preparedness must start before operation begins. Under the DRIP program, Dam Rehabilitation and Improvement Project, preparation of EAP has become mandatory for many major dams across India. This is creating a much stronger safety culture. The first step in EAP development is determine the potentially inundated area. This means we must answer if the dam fails, which downstream area will be flooded. We consider different scenarios. First, fair weather failure. Dam failure when reservoir is at normal storage level. Second, flood failure. Dam failure during inflow design flood. Extreme spillway release. Large discharge without dam breach. Hydrodynamic modeling tools used include HACRAS, Mike Levin, DamBreak, Flow2D, etc. These models simulate flood wave travel downstream. In the Rishiganga disaster 2021 in Uttarakhand, sudden flood wave movement showed how critical downstream flood prediction is. Without inundation prediction, evacuation becomes impossible. After flood routing analysis, we prepare inundation maps. These maps show villages likely to be flooded, roads and bridges affected, schools and hospitals at risk, flood wave arrival time, maximum flood depth, maximum flow velocity. These maps are the foundation of evacuation planning. For small dams with the limited downstream development, a generalized map may be sufficient. For large dams, detailed inundation maps are essential. Suppose flood reaches village A in 25 minutes and village B in 2 hours. Naturally, evacuation must begin with village A. That is why inundation maps save lives. Now we move to identifying the triggers and the response framework. The triggering events, these are warning signs such as sudden increase in seepage, muddy seepage, piping symptoms, cracks in dam crust, slope movement, spillway gate failure, overtopping, unusual vibration. To evaluate warning time, we must know how much time is available. Is it 10 minutes, 2 hours, 12 hours? This changes the emergency strategy completely. Identify stakeholders. This includes SDMA, district collectors, police, SDRF, NDRF, health department, irrigation department, village panchayats. Many disasters worsen not because of the technical failure, but because departments do not coordinate in time. Now the communication system. We must identify primary communication systems, backup communication systems, because mobile network may fail during disasters. These options include wireless systems, sirens, satellite phones, radio communication, control room systems, SCADA alerts. Now the notification flowcharts. These defines who informs whom and in what sequence. Next step is prepare a draft EAP. All information is compiled into a formal document. In several flood events, technical teams knew the danger but failed to communicate quickly. Communication failure itself became a disaster. Now, coordination meeting. This is very important. An EAP prepared only by engineers is incomplete. It must involve police, SDMA, health services, district administration, transport department, because evacuation is a multi-agency activity. Review by SDSO. The State Dam Safety Organization reviews the technical quality of the nationally important dams. CDSO may also review. Often district officers know practical evaluation problems better than hydraulic engineers. Their input improves the implementation. Finalization. This includes incorporating revisions, approvals, signatures, official distribution. The EAP must include a proper distribution list. Updating. EAP must be updated periodically because officers are transferred, phone numbers changes, village expands, road changes, reservoir operation changes. Also, tabletop drills must be conducted at regular interval. An outdated phone numbers during red alert is almost equal to having no EAP. Preparedness means updated preparedness. Now the 5 steps response process. The first step is event detection. Step 2 is emergency level determination. Step 3, notification and communication. Step 4, action to be taken. Step 5, termination and follow up. This systematic process avoids panic and confusion. This is similar to a hospital emergency. That means diagnosis, then severity assessment, then doctor notification, treatment, recovery. Dam safety follows the same logic. Now, the emergency levels. After detecting an unusual condition, the next important task is to decide how serious is the situation. For this, 3 emergency levels are recommended. The first one is the blue emergency. This means the situation is developing slowly and is still under control. There is no immediate danger of dam failure. This is called internal alert. The main objective here is save the dam. Action includes increased monitoring, inspection, immediate corrective measures. Next is orange emergency. This means the situation is developing rapidly. Dam failure is possible if immediate action is not taken. This is called external alert. The focus shifts to save human lives. People must be prepared for evacuation. And next is red emergency. This is the most serious condition that dam failure is occurring or has already occurred. Immediate evacuation is required. There is no time for discussion. This system is like traffic signals: blue, caution; orange, prepare; and red, immediate action. Simple classification improves fast decisions. Now, the event detection flow diagram. This slide explains the complete emergency response logic. It starts with event detection and moves towards emergency level detection or the emergency level determination, then notification, action, and termination. The logic is blue means save dam, orange means prepare for evacuation, red means immediate evacuation. This sequence must be clearly understood by every officer. Early seepage is like fever in the human body. If detected early, medicine works. If ignored, surgery becomes necessary. Same principle applies in the dam safety. Now, step 1: event detection. Event detection is the foundation of the entire EAP. If the problem is not detected early, the rest of the plan becomes useless. Detection happens through visual inspection and instrumentation monitoring. Examples include piezometers, seepage measurements, settlement gauges, water level sensors, rain gauges, crack meters, CCTV monitoring, and early warning systems. Operators must know what is normal and what is abnormal. Mud colored seepage from an embankment often indicates internal erosion. This is one of the most dangerous early warning signs and should never be ignored. The step 2 is emergency level determination. After detecting an unusual condition, the dam owners must decide which emergency level applies. This classification must be quick and accurate. The EAP should clearly define which situation fall under blue, orange, and red. This prevents confusion and delays. If seepage increases slightly, blue; if seepage becomes muddy with slope movement, orange; and if overtopping starts or breach develops, that means red. If every officer interprets danger differently, emergency response becomes chaos. Standard classification creates discipline. Watch condition notification chart. This chart is used during blue emergency. This means the dam is under stress, but failure is not likely if prompt action is taken. This is mainly internal notification. It usually involves dam owner, operation staff, maintenance teams, and engineering experts. Main objective: save the dam. Action include emergency inspection, gate operation, temporary repair, continuous monitoring. Live example: this is like seeing smoke before fire. Quick action can prevent the fire completely. Failure condition notification chart. This chart is used during orange and red emergency. Here the danger is serious. Dam failure is highly probable or already occurring. This becomes external notification. Authorities involves Authorities involved include district collector, police, DDMA, SDRF, public NDRF, public warning systems. Main objectives are save human lives. Live example is when floodwater starts entering villages, there is no time for meeting. Only action matters. That is why this chart must be simple and the fast. Elements of EAP. First is the title page. Even the title page is very important. It must include emergency action plan, heading, official dam name, other common names, project identification code, owner of the operator details, preparation agency, revision number, publication date, last updated date. This ensures authenticity and clarity. Live example is imagine using an outdated EAP version during emergency. Wrong phone numbers and old procedures can create major failure. So, EAP version control is critical. The next chapter in the EAP is the introduction. The introduction explains why the EAP exists. It briefly describes purpose of the plan, flood risk, downstream danger zones, importance of emergency preparedness. The purpose is identify emergency conditions, prevent dam failure, reduce loss of life and property. This section must be short, clear, and powerful. The example is the best disaster management is not rescue after disaster. It is prevention before disaster. Next chapter is the general description of dam. This section identifies the dam. It includes official dam name, commonly used local name, river or stream names, location coordinates, year of construction, year of first impoundment, commissioning year. This basic information helps clear identification. One example is in river basins with multiple dams, wrong identification can cause serious operational confusions. So, precision matters. In the general description of the dam, further, the section include seismic zone, nearby upstream and downstream dams, dam owners details, operators details, dam type. Example of dam types are earth-fill dam, rock-fill dam, concrete gravity dam, masonry dam, or the arc dam. This helps understand structural behavior. A dam in seismic zone 5 requires a very different preparedness approach than one in zone 2. Other descriptions are size classification, downstream population, industries, highways, bridges, railways, power plants. This defines consequence severity. Even a small failure near a city can become a major disaster. Failure near a remote forest and failure near a town are technically different risk categories. So the population matters. Other descriptions are top of the dam elevation, spillway crust level, normal storage, maximum storage, reservoir surface area. These values are critical during flood operation. Live example, when reservoir level approaches FRL during heavy rainfall, alertness must increase immediately. Water level is often the first operational warning. Other descriptions include villages, towns, industrial areas, highways, railway crossing, bridges, power lines, pipelines. This helps prioritizing warning and evacuation. If a bridge gets washed away, an entire district may lose emergency access. So infrastructure vulnerability must be mapped. Now the next chapter is the responsibilities. This is one of the most important sections. It defines who is responsible for what. It includes operation and maintenance, inspection during floods, holiday monitoring, emergency decisions, evacuation coordination, command center management, also line of succession. If one officer is unavailable, who takes over? During emergencies, unclear responsibility becomes everyone's responsibility and then nobody acts. Clarity saves time. Notification flowcharts. This must be placed near the front of EAP. Why? Because during emergencies, nobody reads full reports. People follow flowcharts. They must clearly show who calls whom, contact sequences, backup contacts. Easy access is critical. Emergency decision happens in seconds, not in chapters. That is why flowcharts are the heart of the implementation. Emergency condition and notification. Two emergency conditions are used. Watch condition means the activated during blue emergency. Dam failure is unlikely if corrected quickly. Failure condition activated during orange and red emergencies. Dam failure is highly probable or already occurring. Each condition has different notification urgency. Like weather systems, yellow alert means caution, red alert means immediate action. Same principle applies here. Flowchart element. At least two notification flowcharts are required. They must show who is responsible for notification, who must be notified, order of communication, names and designation, office oblique mobile oblique home numbers, alternative contacts, communication mode. Never depend on only one officer or one phone number. Backup system are really safety system. Notification responsibility. Usually, local government and police handle public warning, evacuation, shelters. But in some cases, the dam owners must directly warn affected people, especially for small dams, isolated villages, immediate risk areas. If only two villages are affected, direct warning by dam staff may be faster than waiting for administrative hierarchy. Speed matters more than protocols. Inundation maps. These are the most critical visual tools in EAP. They show flood spread, flood depth, arrival time, critical structures affected, used for evacuation, rescue planning, warning systems, shelter planning. Without inundation maps, evacuation becomes guesswork. With maps, it becomes science. Progressive refinement of inundation maps. Inundation map improves over time. Initially, simple maps may be prepared. Later, refined using better topographic surveys, LIDAR, updated breach modeling, better hydraulic simulations. EAP should improve continuously. Good planning starts simple but becomes stronger with better data. Perfection is a process. Emergency detection, evaluation, and classification. Detection alone is not enough. We must confirm the problem, evaluate seriousness, classify emergency level. Both false alarm and delayed alarms are dangerous. Balance is important. Too many false alarms reduces public trust, but delayed alarms can cause fatalities. Judgment is everything. Preparedness. Preparedness means action taken before emergency begins. This includes training, drills, coordination, updated records, equipment readiness, public awareness, and the goal is maximum readiness in minimum time. A fire extinguisher is useful only if people know how to use it. Same applies to EAP. Supply and resources. Emergency resources must be identified in advance. These include sandbags, stones, pumps, excavators, generators, fuel, technical experts, transport vehicles. Also, emergency procurement procedures must be predefined. During flood peak, market purchase is too late. Preparedness must exist before rainfall begins. Updating. EAP is a living document. It must be updated whenever officer changes, phone number changes, downstream development changes, reservoir operation changes, new road and settlement appears. A wrong contact number during red alerts can cost lives. Updating is not paperwork, it is safety. Training. Training ensures that everyone knows what to do, how to respond, where to go, whom to contact. Training removes panic. Practice creates confidence. Pilot practice emergency landing many times even if it may never happen. Dam manager must do the same. To conclude, emergency action plan is not merely a compliance document, it is a life-saving mission document. Its purpose is save the dam, save property, save human lives. Preparedness today prevents disaster tomorrow. People remember rescue operations, but true professionals prevent disasters before rescue becomes necessary. That is the real success of EAP. If you found this helpful, don't forget to like, share, and subscribe to Hydrology Hub. Keep learning, keep modeling. This is Hydrology Hub.